Welcome, class. So, in our previous lectures, we've really worked hard to build a solid foundation in mathematical theory. Today, though, we're going to make a crucial shift. We're moving from the abstract to the very applied. We're going to examine a tool that isn't just for exams, but is one of the most powerful and, I'd argue, essential instruments in the toolkit for any of you who will become managers, strategists, or decision makers. Today, we're going to bridge that gap between the classroom and the boardroom.
So let's kick things off with a core challenge that, believe me, every single one of you will face, no matter what industry you end up in. Picture this. You're running a business operation. The board of directors, your boss, they're all looking at you, and they ask a question that sounds simple but is incredibly important. At what exact point do we stop losing money? At what point do our sales perfectly cover all our costs? At what point do we break even? This isn't just an accounting question, class. This is about survival. It's a strategic imperative.
Now, before we even think about touching the math, it is absolutely critical that we frame this problem in the right way. We are not here today just to solve for X because it's in a textbook. We're here to learn how to build a mathematical model of a real business, a model that lets us take messy, complex operations and turn them into a clear equation, an equation that gives us real, actionable intelligence. I want you to think like a manager who's using a powerful tool, not just a student solving a puzzle.
And here it is. This is the fundamental link between what we do in this room and what happens in the corporate world. That parabola shape you studied in algebra, it turns out to be a surprisingly accurate model for how a lot of businesses actually work. Think about launching a new product. At first, you scale up production, your marketing starts working, and profits climb. But what happens eventually? Well, maybe the market gets saturated, or new competitors show up, or your own costs start to rise, paying overtime, straining your equipment, and then profits start to fall. That classic rise and fall curve, that's a parabola, and the engine that drives it is a quadratic equation.
Okay, let's get really precise with our language here. This is the standard form you need to burn into your memory. ax squared plus bx plus c equals 0. Now, in a business setting, x is your variable. Usually it's the number of units you produce or sell, but it could also be the price you set or even how much you spend on advertising. The coefficients, a, b, and c, those are the numbers that define your specific business. C, for example, that's usually your fixed costs. Think rent, salaries, insurance, all the bills you have to pay even if you don't sell a single thing. B often relates to your variable costs. And A, which is often a negative number in profit models, captures those diminishing returns we just talked about. Now listen closely, because this is the most important idea we're going to cover today. It's a translation. In pure math, the solutions to this equation, the values of x that make the whole thing equal 0, are called the roots. Graphically, it's where the parabola crosses the horizontal x-axis. So let's translate that into business language. If your profit equation equals 0, what does that really mean? It means there's no profit, but there are also no losses. You are perfectly balanced. You are breaking even. So finding the mathematical roots is exactly the same thing as finding the financial break-even points.
All right, so we've set our business goal, find the break-even points. We also know we can model this goal with a quadratic equation. So the next logical question is, what's the tool for the job? What is the universal key that can unlock the solution to any quadratic equation a business might throw at us?
This is it, the quadratic formula. And its real power, its beauty, is that it is absolutely universal. It doesn't matter how weird or complicated the numbers from your business model are. It could be huge numbers, tiny decimals, it just doesn't matter. This formula is guaranteed to work every single time. For a manager, that means it's a completely reliable, robust, all-purpose tool for finding those critical break-even points.
Now, at first glance, this formula can look a little intimidating, but the brilliant thing is that we can break it down into a simple, step-by-step process. But I want you to look very closely at step 2. That little piece under the square root, b squared minus 4ac, it has a special name, the discriminant. And this little piece of the formula is amazing because it gives you incredible insight before you even finish the problem. If the discriminant is positive, it means you have 2 break-even points. A point where you enter profitability and a point where you exit it. Super common scenario. If the discriminant is exactly 0, you have just 1 break-even point. And if the discriminant is negative, well, that's the most interesting one. Mathematically, it means no real solution. In business terms, it means your profit curve never crosses the 0 line. That's either a dream scenario where you're profitable from the very first item you sell, or it's a nightmare scenario where your business is fundamentally unable to ever make a profit. The discriminant is a powerful diagnostic tool all by itself.
Okay, let's move on. Theory is great, but you only really learn this stuff by doing it. So we're going to apply this formula to a real, concrete business case study. We'll see exactly how it takes a mathematical equation and turns it into smart, strategic business decisions.
Let's set the scene. I want you to imagine you're the senior product manager for a new gadget. The finance department has done all its number crunching on costs and market demand, and they hand you this profit model. Now notice, the profit is already set to 0. Why? Because our specific goal right now is to find the break-even points, the values of X where profit is exactly 0. In this model, X stands for the number of units sold, in thousands. Your job is to take this equation and figure out the production levels where you're not making money, but you're not losing it either.
All right, following our process, step 1 is to correctly identify our coefficients. Looking at the equation, we can see A is 4, B is -17, and it is absolutely critical that you include the negative sign. B is not 17, it is -17. That is such a common and costly mistake. And finally, C is 15. Now this C value, the y-intercept, suggests that at 0 units sold, the model shows a profit of $15,000. This could represent something like an initial government grant or some other income that helps offset your starting costs.
Now we move to step 3, substitution. We're going to carefully plug our numbers into the formula. I want everyone to focus right on the beginning of that formula, in the numerator, -b. Since our b is already -17, we have a double negative here, minus -17. I really can't overstate how important this little detail is. This is probably the #1 spot where students make errors. And a simple sign mistake here won't just cost you points on an exam. In the real world, it could lead to a completely flawed and expensive business strategy.
Okay, let's just do the arithmetic, making sure we follow the order of operations. The minus -17 becomes a positive 17. Inside the square root, we do the exponent first. -17 squared is positive 289. Then the multiplication, 4 times 4 times 15 is 240. The difference, 289 minus 240, gives us our discriminant, which is 49. And in the denominator, 2 times 4 is 8. See, the equation has simplified really nicely, and now we have all the key pieces to find our answer. So now we get to the final step, where we solve for the two possible values of x because of that plus or minus sign. First, let's take the minus path. 17 minus the square root of 49. Well, the square root of 49 is 7, so 17 minus 7 is 10. Then we take that 10 and divide it by our denominator, 8, and that gives us 1.25. Now here's the crucial final step. We have to translate this number back into its business context. Since x is in thousands of units, our answer of 1.25 means our first break-even point happens when we sell 1,250 units. Now, for the plus path, 17 plus the square root of 49, so 17 plus 7 is 24. 24 divided by 8 gives us a nice clean 3. So our second or upper break-even point is at 3,000 units. Now, as future managers, you should be asking yourselves a really important question here. Why? Why would a company become unprofitable again after it's already successful? This is a classic example of diminishing returns. Maybe you have to pay your workers overtime, or your machinery gets less efficient when you run it 24/7, or maybe you've just saturated the market and have to start dropping your price to sell more units.
So here's the big takeaway. The quadratic formula didn't just give us two random numbers. It has defined a strategic corridor of profitability. As a manager, you can now walk into a meeting and give a crystal clear, data-driven recommendation. You can say, our target for production and sales needs to be somewhere between 1,250 and 3,000 units. If we produce less than that, we won't cover our fixed costs. If we produce more than that, our rising marginal costs are going to eat away all of our profits. That is the very definition of using math to drive real business strategy.
And that old case study is a perfect example of why being precise in your calculations is just, well, it's non-negotiable. In business, a small math error isn't just a mistake, it's a risk. It can lead to a major strategic blunder with very real financial consequences. So let's take a minute to go over the most common mistakes people make with this formula so you can learn to spot them and avoid them.
I really want your full attention here, because getting these details right is what separates the pros from the amateurs. First, the sign error. We've talked about this, but remember, negative b just means the opposite of b. If b is already negative, the opposite is positive. Second, squaring negatives. A negative times a negative is always a positive. Be careful with your calculator. If you type in -17 squared without parentheses, it might give you the wrong answer. Third, order of operations. You have to solve everything under the square root first before you take the square root. And finally, misinterpreting the roots. Never ever forget the context. Getting the answer x equals 3 is pointless if you don't translate that back to what it means for the business, 3,000 units. In business, context is everything.
And we'll end with a thought to take with you. What we did today, finding break-even points, that's really just the beginning. It's the first step. The very same quadratic equation that showed us our profitable range also holds the secret to optimization. The very peak of that profit curve, the vertex of the parabola, can be found with a simple formula. X equals negative b divided by 2a. And what does that tell you? It tells you the exact number of units to produce to make the absolute maximum profit possible. And that takes our analysis to a whole new level. The question changes from how do we break even to the much more powerful question, how do we become maximally profitable? That right there is the heart of modern business strategy, and it's a question you are now all equipped to start answering.